Now, as you have seen before, we are using actually Postman to test out our application, and well, there's no documentation as of the moment. As We have no documentation as of the moment to help other developers to see how our API works. The thing is, even if we put really good documentation on our code, other developers will need to see the code first to be able to understand how it works. So, to help them out, what we'll need to do is to create a way or a website to document how our API works. And we don't need like any fancy web app as of the moment. We'll do that later, but the thing with that web app is it's actually the web application for creating a to-do and not a documentation page. So for us to create a documentation page for our application, this is also one of the reasons why I use Fastify, is because I can install. So let's clear this up. Clear, and let's install Fastify Swagger. Wow, Swagger, swag. So Swagger is another name for the Open API initiative, where if you look in, or if you query or search it in Google, you'll be able to see a standard of creating a documentation for your web API. So now that we have installed it, we'll just add it up on the app here. Const Swagger require Fastify. Fastify Swagger here. And once that is done, what we need to do is to set up its options. So app.register Swagger and the options. Now the options would have what would be the prefix, meaning what would be the URL to show your documentation, and if we should expose that route, so that's true, and then the Swagger info. So let's set it up. We'll have the title, description, and version, which we will get from our package. So from our package, we will get const name, title, description, and version coming from our package.json. If you look at our package.json, there's the name, description, and version. So we will use those values. So that would be title, description, and version. Now, what would be the schemes available? Would it be able to do both HTTP and HTTPS? So for now, we'll use both, but of course it will not work with HTTPS because we haven't set up any way to read it from port, the HTTPS port, and what it should consume. It should consume the application JSON object. What would it produce? It would produce the same. And then what would be what would be the definitions? The thing with definitions is this is where we create the documentation for our for the request and response. So what I would do is to create a new folder for it. Definitions. Let's create a new folder which index.js, and for this one we'll just export definitions. Now first things first, let's try out what would be the definitions that you want to see. First and foremost, when we are designing an API, we would need, of course, okay, there's an ID. What is an ID? How do we define an ID? What is the text? What is done and what is date created and date updated, so on and so forth. So let's define those things here. So let's say we have a unique ID. It should be a type string. The description is a unique identifier. Value is, let's say, this value, and an example is the same. So this is how we build our definition. Now we also have, let's say, const text type string, any textual string. Value is, let's say, hello world. An example. So let's just follow what I'm writing as of the moment, and we'll show you how the magic works. Then we'll have const done. Type is a boolean. Description is if a to-do object is done or tagged as done. Of course, the value would be true. An example is true. That we are done on those things. Now let's define const. Let's just add the word data at the end, so as not to have a conflict on a existing keyword like date, because I'm going to use data here. So it's a type of a number description, a date value that is in Unix epoch. And the value is, let's say, this one. Example is this one. Now after that, we'll have, of course, I'll just copy this. Success data, state of a response, and let's just try out const success response. Now it's time for us to create a response here, which is a type object. The description is response with a success state only, and the properties is success data. So now we are using this. So success response is part of the definition. So let's try it out on the index itself. Now for us to be able to use that in the app, let's go for the app first. Let's define the definitions. So const definitions require definitions. Then from this one, what we will show is what we will create is a schema. Schema would be, so we are now defining the schema of our system. So server root route tags is root. Yeah, it's an array of keywords. I usually just say the same thing as the description for the summary. There is no params, so we have response. We define that if it responded with 200, it will do a success response, which comes from the definitions as well. So success response comes from definitions. Now let's test it out. Oops. I forgot this one. There you go. There you go. So if we go to our page here and add docs, we have essentially created our own documentation. As you can see here, there are no parameters because we haven't set the definition of the schema, but for the root, we are able to set that if it's 200, it's a success. Check the model. There's the description and what would be the example value. If we try it out, execute, we don't need the postman anymore. It will show the response and response headers. And yeah, it seems that it's working. So what we will need to do is to also update all the other things here. So let's just try out first getting the to-do. We try it out. We'll get all of these things. But we only actually needed text ID, done, and date created and date updated. So let's go to get many. Let's define the schema. Oh, not in this part. Let us oh, now I realize what I did wrong. For this one, for get many, instead of having directly the function, which in essence it works. We should define first that this is a handler. There you go. So let's have this for get many. Don't need the response. Yep. Yep. Be like this. So what I did here is to create an object that has has a handler, and we'll have a schema here as well. We'll get the schema set up that we have in our index. And let's change the description to gets many to-dos. And to do. Of course, the response should not be success response. So what we will need to add in our definition is what would be the response for get many. So let's create first the user data. Oh, not user data. The to-do data that we will be setting up, which is a type. Let's say full. Full data. Object. Description. To-do object data coming from the database. Properties. We have already set the things above, but let's just try it out. ID, which is the ID, unique ID data. Text, which is the text data. Done, which is the done data. Date, updated, which is the date data, and date created, which is the another date data. Now, given that, you want to say that a get many to do response is a type object description returns a list of to-dos. Properties are as follows. So let's have another const to-do list data. Type is an array. Description is a list of to-dos. Items is just the to-do to-do full data, and the properties is success. For this one is success data, and the data is to-do list data. Now we will put a required here, which is a list of objects or list of items that should exist. Now that we have that, we'll put it here, and then go back to above. get this. Of course, reference the right definition. Then, as you can see, we have other items, which is underscore underscore v and underscore id. But if we refresh this, now that we have a to-do here, we are expecting this setup. So if we try it out and execute, we only get the necessary items. And that is something that is good in terms of documentation, because we are seeing what we are expecting. Now, one of the things that is not included here as of the moment, which we haven't put, is how do we set up the query parameters. So to set up the query parameters, we use query, and instead of like the usual, so we again go back to the definitions, and let's say we create a query parameter. So go back up. I just want to go here and add query limit data type number, description is limit of how many items we should query, value is, let's say, 4, example is 4. Then we also have, oh no, we don't need that. So limit data, so we will need to get many to do query, which is a type object. Description is the query parameters for getting many to-dos, and then the properties are limit, which is limit data, and start date, which is a date data. Given that, we add it in our definition so that we can access it. So we use get many to do query and put it here. Now that once we have saved it, we refresh, and you can see that in our to do there is now this setup, because we have put in the documentation. If we execute, if we remove this, that means we can have we don't need to have start date, but we have a limit, and you'll see that this is the way how we call it, and it will show you that it's now returning 4. If we do 6 and execute, it will return 6. This is the request URL that we have tried, and this is how it will turn out. So if we did the date update here, so copy and then put it here, it should just show 3 even if we have 6, because we started from this one going up. What we can also do is add an additional definition, which is end date data. Then from our setup, we can define that if there's an end date. So for us, so once we add end date, it's better to create an options, separately, and if there's a start date, we will set options to have options that date updated is equals. Now this is to check if it already exists, or have an empty object. And let's put in options that date updated. Well, because this is the first one, so we don't need to check if it's already done. GTE is equals to start date, and if there's an end date, now this is where we get this previous one if it has a start date, or if it doesn't have a start date, gets this one. Then options dot date updated less than or equal end date. There you go. We delete this. Then test it out. Oh, before we test, yep, there it is. Now we try it out. Remove this. Try to start with, let's say, this one. The end date would be this one. So that means we should only get this. And if we want to start from here, we should get only 2 items. So this is what you see, and this is what we get. Now, given that, let's try it out in a test. Most likely we have already something that we haven't tested, which is the end date. So we have to add that part. Limit to get. Here's the start date. Okay. Here we have it has status code when called using get. It has default limit 3, and it should be descending order where the last item is updated on or after. Okay, so I know now why it's having an error on this one. It is because we are starting from the highest to the lowest whenever there's a start date. So we should, if there's a start date, we should have a 1, else it's start date and no end date. Now after that, we just force everything to be sorted the usual way. Prev next is if next date updated minus prev date updated. Now let's try it out for this one. Execute. There you go. Everything is sorted. If we test it again, force sort to do a descending order. Then for the test, yep, it works now. For the test, we return to have it randomized. There you go. Get many. This forces to start the query on start date if and when start date only exists. So there you go. That's how we understand, or well, there you go. The reason again is that if we do a descending order and we only have a start date, and let's say the limit is only 3, it will always start at the very last of the collection, meaning the latest date updated. And if the start date element is like in the 5th and you only have the limit of 3, it will not show up on the query. But if we force it to do an ascending order first, it will start, or it will get the element, or it will get the document from the collection or from the database, and we just have to add a force to do a descending order in this one. So if we want to make it a little bit more performant, we just check if there's a start date and there's no end date. So that means this part will only run if it's in the ascending order. So let's do a test again. Let's see if it works. Everything should be in 100, and we should have get many. As we can see, everything is working. Now after that, we'll add a little bit more. Here now, we just make this a handler function rather than just a function. There you go. That would also mean yep. That's the error. Put it here. Of course, it will crash. Nope. This one. Yeah, there you go. Then we'll add a schema, same as, well, we'll have a schema here, but instead of using delete one to do yes, And then we have a params object, which is to get one to do param, and this should be a success response. We get it from the definitions. Well, now we don't have get one to do params, so we define it again in the definitions. Just put it here, and then const get one to do params. The type is an object. Parameter for getting one to do, which the property is a unique ID data. So given that, that's the delete option. We have a success response. If we check our setup here, we save it and refresh, and we have the to do, we have the parameter, and there you go. Now let's add the same thing in create. We do a schema for create, and instead of params, we have a create get one response. Let's just do that. Post to do get one to do response, post to do request. So let's have those. Let's have the body to be this one. We have, oh, not that one, and this is a request. So let's do that. Oh, it crashed because we don't have it yet here. Get one returns a to do, so it should be a to do full data, and the post. What's that again? Post to do. So we do this. Database should be that's something, and then we put a required. Now, the cool thing here is we put a required text, and then post to do request. The cool thing with this one, okay, definition is not yet defined because I think I forgot to get the definitions on this one. We just copied. Yep. So the cool thing with to-do request is, let's try it out first. Refresh. Post to do. So here, let's try out without the required. So let's comment this out. And we try it out and remove the text. So execute. And it will... Oop. I think we have, yep, application. Okay, execute. We refresh the whole thing, try out, execute, and we get to see this one out that we have defined before. But if we go back and return the required text and execute, we'll see this one. Bad request, body should have required property text. So in essence, if we do this in create, if we remove this one, so let's remove this, which is the one that says if text doesn't exist, and refresh it, try it out, put it here, execute it, it will still have an error because our schema has defined that in the post to do request, in the definitions, we require a text, which is a very good setup. As you can see, let's try it out. In the model, it has like this part where it means that this is something that we need to put. Okay, so we have create. For get, we have to put again, this one. So let's have a handler. There you go. Then let's move this one here. Then let's have a schema, which is this one, but instead of success response, copy the whole thing, put it here, and it's instead of using this, we get this one and get one to do response. We define this as this one, and we'll check out if it works. Save, refresh. We'll see that there's the get to do, and now it's also in here. You have the delete, and last is the update. So we'll just get this one again, put it at the top, make this as an object with the handler as the handling of the function. We indent it so that it's a little bit more predictable to read. We do this schema, but instead of post, we use put to do request. And get one request. We just update the definitions to have a put, which is actually just a post to do request, but doesn't have a required. So we rename it. Oh, not this one, but this one. Data for creation, data for update. So let's see. Update. What we need as well is the get one to do params. And if we refresh the whole thing, it should work. This is to do. There's the put, and we have the body, and we have the ID. Now let's try it out for testing. See if it works. Nope. So for create, well, of course, it doesn't have an error, so we'll have this for now. We remove the console IDs because we don't need anymore. Don't need it anymore. There you go. Let's test it out again. $31. Of course, we don't need this because we expect it to have a payload. It will have an error on our end. And on update, we don't need line 33 as well because we expect to have a body in essence. It will always return an error if we don't have a payload because we are expecting it to have one. Oop. Where is this update test? Because we don't have a success. Where is it? 159. Yeah, this one. Of course, we don't have yet code in there. Yeah, there's no payload. Yeah, I'll tell you why there's no code. It's because it's using, so if we do a put here and we don't send a payload, or let's just have the post. Oh, still saying delete. There's no text. It uses this one, which is a little bit problematic. We don't have the success. We don't have the usual setup, and we will fix that later on once we install something. But for now, we have this and it works. Let's just change the post, because it says delete where it has to be create. So again, these things we need to remember. So create one to do, get many to do's, get one, delete. Okay, on put we update it as well. Update one to do, and there you go. Mission accomplished. Let's add everything up. Let's see what we have changed here. So let's just add these things first. Sure, add Fastify, Swagger, depths. Now, what are the changes here? Feet, add Fastify, Swagger, initialization. That is, yep. Feet, add definitions for request and response. Now that we have that, now thing is, feature add schema to all routes. Test, add test for getting add test with end date. Test remove success for now. Yeah, and that is how we add a schema. The next thing we'll need to do is to go to the next video.